Hi, everyone. Welcome to our next video for week 7, where we're going to introduce the concept of ANOVA. So what is ANOVA? One-way ANOVA, also known as one-way analysis of variance, is a type of hypothesis test used to compare 3 or more means. It's called analysis of variance because the test uses variances to determine if the means are equal. This test determines the means are not equal. We have to perform further tests to locate which mean or means are different from the rest. You'll notice this is a test of means. We've done this before about 2 weeks ago. We talked about using a z-test or a t-test to test a claim about a single mean or to compare 2 means. We can use those tests to compare 3 or more means, but we have to do them pairwise, 2 at a time. ANOVA allows us to compare all of the means at the same time, meaning running one test as opposed to several tests pairwise. And it does that by comparing variances. How variable is the data about its measure of center? There is a downside. If we do find that there is a difference between the means, we have to perform pairwise tests to find where that difference is. But this does cut down the number of tests if there isn't a difference, because then we're done with the process. ANOVA uses a new distribution called the F distribution, which again is related to variance. We're going to be using a calculator to find the p-value, so we don't actually have to worry about what the F distribution looks like or how it works. It does kind of look like a chi-squared distribution, because again, it's related to variance, so it is skewed to the right. If you want more information about that, there is information in your textbook in sections 13.2 and 13.3, or you're welcome to drop by office hours this weekend. I can go over some of the finer details. As far as you are concerned for this class, you should know it's an F distribution test, but you don't need to know any more than that because your calculator is going to do all of that calculation with regard to the distribution in the background for you. Yay, modern technology. So let's talk about how to perform that ANOVA test. So we're using our standard p-value method for hypothesis testing. So state hypotheses, identify claim, calculate the p-value, make a decision, write a conclusion. So the hypotheses for an ANOVA test always going to look the same. For the null hypothesis, we're assuming all of the means are equal. And I usually write this with symbols, but you can write that in words. All the means are equal. Mean 1 equals mean 2 equals mean 3 equals however many means or however many groups you're comparing. The alternative is that at least one mean is different from the rest. So we know there's at least one person that doesn't match the rest. For finding the p-value, we're assuming that we have raw data for a sample. And we're going to enter those data points into lists. So each of the 3 groups for the means that we're comparing go into their own list. The lists do not have to be the same length. You can have a sample from one group that's smaller than a sample from another, and that's okay. And then you're going to call ANOVA and enter the list names. This is the one function call we're using that is exactly the same for TI-84 and GeoGebra. For the TI-84, you have to go to the stats test menu, and ANOVA should be the very last test at the very bottom. For GeoGebra, you just type ANOVA and then the parentheses and then your list names. So probably the least complicated of the p-value calculations we're doing, which is nice. A review for decision making, if the p-value is less than or equal to your alpha, we reject the null. If the p-value is greater than the alpha, we do not reject the null. I'd like to review writing a conclusion because I noticed when I graded some tests that seemed to be a struggle point for us. So remember that there is a table with sentence frames for you. And this works for pretty much every hypothesis test we're performing except the test of significance. But even with the test of significance, you can use this. And it's sorted by the decision that we made in step 3, reject the null or not reject the null, and then whether it was the claim or the null as the claim or the alternative as the claim. So you'll notice in the reject column, there is enough evidence, there is enough evidence. So when we reject the null, there is enough statistical evidence to make a decision. Whereas in the do not reject null, there is not enough evidence. And then with the claim is the null row, you'll notice that keyword reject in both. There is enough evidence to reject, or there's not enough evidence to reject. Versus the claim is the alternative, we talk about support. There is enough evidence to support. There is not enough evidence to support. And you'll notice that sentence frame has a ... at the end. Once you've stated your decision in words about the claim, you should summarize what the claim was. Meaning a person that's reading your conclusion should not have to go back to the original word problem to figure out what's going on. So that was an introduction to the to the process. In the next video, I'm going to do a couple examples from start to finish in both the TI-84 and GeoGebra so you can see what those processes look like in practice. If you have any questions, let me know via email or drop by office hours Tuesday, Thursday, or Friday. And I hope you have a great rest of your week.